For this section, we'll be talking about rational expressions. And a rational expression is essentially a polynomial divided by a non-zero polynomial. Basically, it'll look like a fraction with x's. So, because we're going to be dealing with fractions, we should go over some basic rules. The first rule is whenever we have AC divided by BC, meaning we have just multiplication in the top and bottom of our fraction, we are allowed to cancel the common factor in the top and bottom, leaving us with just A over B. So, just to be clear, the most common mistake that happens with this is when you have addition or subtraction, people will cancel the common factors. That's not how it works. It's only the terms that are being multiplied together that allow you to cancel out one of the terms. If one of the terms is, for example, an x plus 2 that's being multiplied in the top and bottom, then that is perfectly okay to cancel, otherwise only with multiplication. And we'll get into all types of examples like this. From here, we have another rule that says to multiply two fractions, if you have A over B times C over D, you multiply straight across, which gives you AC over BD. And the last rule out of these three is if you are dividing fractions, A over B divided by C over D, you use the copy dot flip method. You copy down the first fraction, you change it to a dot, meaning multiplication instead of division, and then you flip the second fraction. Instead of C over D, we have D over C. And now, again, when you're multiplying two fractions, you just multiply straight across, which gives us AD over BC. So let's go ahead and try out these rules, given the following example. So, before we go into this example, I do want to mention this process that says to simplify a rational expression, the first step should be to factor the numerator and denominator. Once you factor them, you will cancel the common factors. Remember, that was rule 1. And then you will leave it completely factored. So, going back to this example, notice we only have addition and subtraction between all of our terms. We can only cancel if there's multiplication, so we have to change it to multiplication by applying step 1, factoring. So, looking at this problem, we need to factor x squared minus 6x plus 9. We'll quickly use the guess and check method for that. We need two numbers that'll multiply to give us x squared. Well, that's just x and x. And we need two numbers that multiply to give us 9 and add up to give us negative 6. We could use negative 3 and negative 3. And that's completely factored. You could use a quick check to prove that. But the check is only required when the problems are purely about factoring. This is just an intermediate step. So from here, we now have 2x minus 6. To factor this, we have a common 2 between the terms that will factor out, giving us 2 times 2x divided by 2 leaves us with x, and negative 6 divided by 2 gives us minus 3. And now notice we have a common factor in the top and bottom. We are only multiplying. We're multiplying these two terms and these two terms. So we can cancel out the common term in the top and bottom, leaving us with just x minus 3 over 2. This is the simplified form of that original problem. Later on in the course, we'll get into scenarios where we will explain that these two are not technically true. if you were to go about graphing them on your calculator, you might even be able to pick up what that issue is. But essentially, whenever you cancel a common term out of the top and bottom, you introduce a hole in the graph. And that hole is something that we have to make note of, because you technically couldn't plug in the value x equals 3 into this original problem without getting division by 0, but you could plug it into this one. So it's something to be aware of. We'll get to that later on. So from here, we're going to go through another problem, and then I'll have you all try the next one. We need to simplify this problem as much as possible. So the first thing that we have to do here is to factor every term, every polynomial, that is. So first, starting with x squared plus 2x plus 1, we can factor that using guess and check again. We need two numbers that multiply to give us 1 and add up to give us 2. That's just 1 and 1. The denominator does not factor, so we'll just leave that x plus 3. Divided by, and now we need to factor x squared minus 1. Notice that looks like a difference of squares whenever you only have two terms in subtraction. So if we use a difference of squares formula, we want the square root of the first term, which is x, minus the square root of the second term, which is 1, and then again the square root of the first term, which is x, plus the square root of the second term, which is 1. And that's all over x squared plus x plus 6. We'll check if we can factor that with guess and check as well. We want two values that multiply to give us x squared. That's x and x. And now two numbers that multiply to give us negative 6 and add up to give us positive 1. So that'd be plus 3 and minus 2. So at this point, we now just need to take care of the division. So for this division, we need to use the copy.flip method. We copy down x plus 1 times x plus 1 over x plus 3 times, and now we flip the second fraction. So x plus 3 times x minus 2 all over x minus 1 times x plus 1. And now that we have it flipped, we can combine this all into one fraction and cancel our common terms. Another thing to note is that whenever you are multiplying two fractions together, you can cancel any common terms in the top and bottom of either fraction before you even combine them, meaning this x plus 1 will cancel with this x plus 1. And this x plus 3 will cancel with this x plus 3. This only works with multiplication, though. So this all leaves us with x plus 1 times x minus 2 all over x minus 1. And that is the simplified form of this original problem. At this point, I'd like you to take a moment, pause the video, and see if you can't solve this top problem. Okay, so going through it together, we have x squared minus 4 divided by x plus 1 times x squared plus 2x plus 1 over 2x plus 4. We start by factoring immediately. X squared minus 4 is a difference of squares. We get the square root of the first term for each of our first terms, and the square root of the second term for each of our second terms. So the square root of 4 is just 2. The square root of x squared is just x. And now we have a minus and a plus. Remember that difference of squares formula will come up all the time in mathematics, so it's good to start committing that to memory. From here, x plus 1 does not factor, and we have times x squared plus 2x plus 1 does factor. Using guess and check, this is actually one of our formulas, just like the difference of squares. But we can just use guess and check very quickly. We need two numbers that multiply to give us x squared, so x and x. Two numbers that multiply to give us 1 and add up to give us 2, that's plus 1 and plus 1. And now, is there anything common between 2x and 4 that we can factor out? We have a 2. So we have 2 times 2x divided by 2 is just x. 4 divided by 2 is just 2. And remember, from here you could combine this all into one fraction and then start canceling common terms, but we can just do that immediately. We have an x plus 1 in the top and bottom that we're going to cancel out, and we also have an x plus 2 in the top and bottom that we can also cancel out, which leaves us with just x minus 2 times x plus 1 all over 2. Another very common mistake that happens with these problems is people will see that they have, for instance, an x minus 2 here and an x minus 2 here, both in the top. You cannot cancel those. It has to be in the top and bottom to cancel out. Alright, so from here, we'll move on to the next type of rational expression problem we have, which is another rule from fractions that hopefully you've seen in the past. It's if we have a over b plus c over b, then when you combine these fractions together, you will keep the denominator. As long as you have a common denominator, you can add them together, keeping the original denominator and just adding the numerators. So we get a plus c all over b. And this works exactly the same way for subtraction. Okay, one thing that is worth noting is if you do not have this common denominator, then you have to find it. You need to find the least common denominator, which we will show an example of. So, for these problems, I'm going to go ahead and go through the second one with you, and then I'd like you to try the first one on your own. So, this problem says 8x over x squared minus 16 minus 4 over x minus 4. We want to simplify this. The first thing we need to check is, do we have a common denominator? Well, here we have x squared minus 16, here we have x minus 4. They're obviously not common, so we need to find a least common denominator. And the way you do that is by first factoring. So we need to factor x squared minus 16. Hopefully you can see that that's a difference of squares again. So we break it up. The square root of x, the square root of x squared is x. The square root of 16 is 4. And we put a plus with one and a minus with the other. We have a difference of squares factored now. Minus 4 over x minus 4 does not factor, so we just leave it alone. And from here, now notice we have a common x minus 4 in each denominator. So to get the least common denominator, we need to have an x plus 4 with each of them as well. So this right fraction needs to be multiplied by that missing factor in the denominator. But when you multiply it to the denominator, you have to multiply it to the numerator as well. Otherwise, you're changing the problem. If you multiply it to the numerator and denominator, then it's like you've multiplied by 1. Because if you take x plus 4 and divide it by x plus 4, anything divided by itself is just 1. Okay, so with that, let's go ahead and start simplifying. We now have 8x over x plus 4 times x minus 4 minus 4 times this x plus 4 over x minus 4 times x plus 4. And now that we have our common denominator, we can combine our like terms. Sorry, let me say that again. Now that we have our common denominator, we can subtract, is the better way to say that. So, we won't be able to combine the like terms until our next step, really. So, from here we have 8x, and we are going to subtract this 4 times x plus 4 all over x plus 4 times x minus 4. And now it's a matter of simplifying. We can distribute this negative 4 that's on the outside of these parentheses. I'm going to pick back up on the right side of the page. So we have 8x minus 4x minus 16 all over x plus 4 times x minus 4. Now we can combine our like terms. 8x minus 4x is 4x minus 16 all over the same denominator again, x plus 4 times x minus 4. And now we factor once again. So 4 is a common factor in the top. We will factor it out, which gives us 4 times x minus 4. 4x divided by 4 is x. Negative 16 divided by 4 is minus 4. All over x plus 4 times x minus 4. And finally, from here, notice we now have a common x minus 4 that's being multiplied in the top and bottom that we can cancel out, leaving us with 4 over x plus 4. So 8x over x squared minus 16 minus 4 over x minus 4 is just another way of saying 4 over x plus 4. From there, this problem is a lot simpler, but still worth going through. I want you to take a moment, pause the video, and see if you can't find 3x over x minus 2 minus 6 over x minus 2. Try to simplify that. Okay, so now trying this together, we check if we have a common denominator, which we do in this case, x minus 2, so we can immediately subtract, which gives us 3x minus 6 over x minus 2. From here, we check if there's anything that'll factor. We can factor out a 3 from each of these terms. So when we do, we get 3 times 3x divided by 3, the 3 that we just factored out, that is x, and negative 6 divided by 3 gives us minus 2, all over x minus 2, and from here the x minus 2 is now a common factor in the top and bottom. We can cancel the entire thing, leaving us with 3. So 3x over x minus 2 minus 6 over x minus 2 is just another way of saying 3. But again, once we get further into the course, we'll talk about why that's not always true. Because if we would have plugged in x equals 2 into this original problem, we would have gotten division by 0, which is impossible. All right. So the last topic from this section is what we call complex rational expressions. And a complex rational expression is essentially just a fraction inside of another fraction. So to simplify these types of problems, we have to start by finding the LCD, the least common denominator, of all the inner fractions. And once we do that, we will multiply that to every single term. And when that is multiplied to every single term, it will eliminate all of the inner fractions, and then we can just simplify like any other rational expression. So, looking at this problem, we're going to start by finding the LCD. So in this first fraction, we have an x. In this second fraction, we have two x's. X squared means x times x. Well, one of them was already taken care of in this fraction, so we only need the other one. From here, we have a y. And then here, the last one, we have a y squared. Well, again, we don't need 3 y's because one of them is already here. So we only need one more y. So our LCD is x squared, y squared. That's what we're going to multiply to every term. So, over here, we'll multiply the second fraction by x squared, y squared. We'll do the same thing over here, here, and here. This is just a faster way of multiplying this least common denominator to the numerator and denominator of our larger fraction. But if you're more comfortable just going about it that way, that's perfectly fine as well. So when we do this, if we put all of these x squared, y squareds over 1, because it's perfectly okay to put anything over 1, it doesn't change the problem, then what can we cancel from every one of our fractions? Well, in the first one, in the top left, there's an x that's common in the top and bottom. We can cancel that out, so we'll be left with just x times y squared in the top left. No more fractions because everything in the denominator was canceled except 1, and the 1 doesn't matter. Plus, over here we can cancel an x squared from the top and bottom, leaving us with just y times y squared, which is y cubed. In the bottom left, we have a y squared in the top and a y in the bottom. We can cancel one of the y's from the top and bottom, leaving us with x squared y. And then plus, over here, we have a y squared in the top and bottom that will cancel out, leaving us with x times x squared, which is x cubed. And now it is no longer a complex rational expression. It's just a rational expression, just a normal fraction. So we just factor and cancel the common terms. In the top, in the numerator, we have a common y squared between our terms. We will factor that out. In the denominator, we have a common x squared between our terms. We will factor that out, which leaves us with y squared times what's left from xy squared if we take out a y squared? Just x. Plus, what's left from y cubed if we take out a y squared? Just y. And that's all over. Taking out an x squared, we have x squared y. We factored out an x squared from it, or we divided it by x squared. We'd be left with just y plus x cubed divided by x squared would leave us with just x. And now notice what we can do here. We have an x plus y divided by y plus x. That's the same thing. In addition, it doesn't matter which order you put it. It's the same value. So we can cancel this factor, leaving us with y squared over x squared. And that is the simplified form of this large, complex rational expression that we started with. All right, so from here, this is the last problem we have for this section. I want you to take a moment, pause the video, see if you can't go through it. Okay, so trying this together, we're going to start by finding our LCD. We have a 5 here. Here we have an x, which we don't have already, so we'll include it. Here we have a 5, but we already have one of those, so we don't need to include it again. And here we have an x, but again we already have one of those. We do not need to include that again. So our LCD is just 5x. That's what we're going to multiply to every term. And again, we can always put it over 1 to make multiplying by fractions easier. Now in the top left, notice we have a 5 in the top and bottom. We can cancel that out, leaving us with x times x. That's x squared. Minus, here in the top and bottom we have an x, which will cancel out, leaving us with 5 times 5 is 25. Over here, there's a 5 that'll cancel out, leaving us with just x times 1 is just x. Plus, in the bottom right, there is an x in the top and bottom that will cancel out, leaving us with 1 times 5, which is just 5. This is no longer a complex rational expression, so we will just factor and simplify. X squared minus 25 is a difference of squares. We take the square root of the first term and put it in each of our first terms. The square root of x squared is x. We then take the square root of 25 and put it in each of our second terms. The square root of 25 is just 5. And always remember, we make one positive and one negative. And that's all over x plus 5. The parentheses are totally optional here, for the denominator, that is. And now notice we now have an x plus 5 in the numerator and denominator, and we are only multiplying. So we can cancel out this common x plus 5, which leaves us with just x minus 5.